All right, today's the day. We're gonna get the pumps installed. I've got right here in front of me, the first one, this is the Scala 1. This is a little jet booster that's gonna go on our rain collection system to help water our garden with free water. The other one is gonna be the Comfort hot water system. And this is my daughter who's gonna, supervise some of this. And that one's gonna go in our mechanical room, which is right there, and hopefully help us to get hotter water faster.
Let's hold that thought for just a second and back up. What is a hot water recirculation system anyway? Well, simply put, it's a system that keeps hot water circulating through your pipes so you don't have to wait for the water to heat up every time you turn on the tap. It's actually a really great fit for most households in the US, like mine. Most people don't realize that there's actually a solution to this long wait for hot water, and it's actually pretty affordable, typically ranging from $200 to $400 depending on your market. So my employer wanted to get some of these in employees' households so that we'd have a little bit better idea of how to explain it and show to people what they're really like. So they gave me one of these to put in. So that's what we're going to do. But I'd like to take a second just to have some pros explain it themselves to maybe get a better idea of how they sell it.
A big question I get from homeowners is how to get hot water to a fixture faster. There's a couple different ways of doing this, and it depends on what kind of water heater you have, but here we have a recirculating pump from Grundfos. The line consists of Alpha HWR and Alpha Comfort. One is for if you have a dedicated line, and one is if you don't. Dedicated line is where you have a water line run from your water heater to either the furthest fixture, sometimes a kitchen. It eliminates the wait time, so when you open up that faucet, you're going to get hot water right away. Not everybody has a dedicated line. Not everybody has the capability of running a dedicated line. The retrofit would just be an astronomical amount of work. That's where Alpha Comfort comes in. Alpha Comfort maintains a minimum temperature at your furthest fixture. Installation is super easy. It does have an integrated digital timer in it. So if you want to quit wasting water and you want to eliminate that wait time, definitely check them out.
Waking up at 5 a.m., I have to shower to start my day. And nothing's worse than waiting up to 5 minutes to get hot water. This little device can save you up to 12,000 gallons a year. What people don't realize is they're getting charged for water and disposal. What this does is it recirculates your hot water, puts it back into your system, and you're not wasting any water or having it run for up to 5 minutes just for it to get hot. For a couple $100, this is a surefire way to get hot water, save on water, and save money.
Right, so here's a diagram from one of our installation manuals. You've got cold water coming in from your city, which is piped to all the fixtures in your house. At the beginning, it splits off to a water heater and another set of pipes that carry hot water to your faucets and other fixtures. Now here's where the magic happens. You add a pump right after the water heater, but then there's a clever part. There's also a special bypass valve on the pipes at the fixture furthest from your heater. This valve has a cool trick. When the water in the hot pipe cools down a bit, the pump moves it through the valve back into the cold water pipes instead of letting it go down the drain and be wasted. Meanwhile, the hot water from the heater reaches the valve, which closes when warm, keeping the hot water right there, nice and toasty for when you need it. Now that you know how the system works, I want to do a couple of tests to see just how long it takes to get hot water in my house at a couple of different fixtures before we get the installation done.
All right, so a week from today, I'm going to get a couple of pumps installed. One of them is going right behind me in our mechanical room back there, and it's the Comfort UHWR. I've actually been waiting for this product for years. I was on a development team at one point where we were trying to make it. So the fact that it's a reality is just super encouraging to me. But I wanted to see how long it takes for the water to get hot at the faucet right here in our bathroom that's about 15 feet away. So I've got a stopwatch here on my handy other phone, and I'm going to run the hot water, and we're just going to see how long it takes until I notice that it's warm. All right, so here we go. Assuming this is like a ½ gallon per minute faucet, we'll see how much water is wasted just waiting for it to get hot. 20 seconds. So I do have a tankless hot water heater, and it does need a certain amount of flow to even kick on and start heating the water. That's part of the issue. It's great, once it gets hot, it stays hot for a long time. But if you're waiting for it out of a half gallon a minute faucet, it's gonna take a while. Right at 50 seconds, 60 seconds. So that's a half a gallon gone. Doesn't feel a whole lot warmer yet. For a lot of tankless heaters, a half a gallon a minute may not be enough to kick it on. That's one of the things that I'm interested with this system, to see if it can help that process. All right, now I'm starting to feel it get warmer. It's lukewarm at best. We're at a minute and a half almost right here. That's warm. I wouldn't call it hot. 150. Okay, now I would consider it like hot for actually washing my hands. Right about 2 minutes. 1 gallon of water completely down the drain just to get hot water. That's one of the things I'm really interested about fixing with this system, because the water gets recirculated right back to where it came from instead of going down the drain. And I only get charged for it one time, and I actually get to use all of it instead of it going down the drain. So we'll see what happens in about a week.
It was at this point that I decided to get just a little bit more scientific. All right, so I need to go take a shower, and I wanted to test how long it takes for the water to get hot. I've got this little temperature probe. I have an app on another phone that will tell me what the temperature is in this probe. So I'm going to put it in the water stream and watch the temperature. When it gets to about 100 degrees, I'm going to stop my stopwatch to see just how long it takes. So let's give it a shot, shall we? I hope my probe doesn't go flying off the side there. So 92, 93. I can feel the warmth coming off here. Now that may be about as hot as we get. Okay, 95. When we get to 96, that's the temperature of the valve. They're right there. A minute and a half. That's about the temperature that the comfort valve is supposed to turn off. But you get the idea. It's going to take about 2 minutes to get to hot water. And that's the shower, which is in our master bathroom, which is actually directly above where the water heater is. So 2 minutes to hot water. Let's see if we can change that when we get the pump installed here in a few days. All right, we're finally back to installation day. Here in this picture, a couple of my coworkers came to join and watch the installation. We've got Becky and Kevin. They are both in our domestic buildings division, and they work with these products a lot more than I do. So they wanted to see how everything was coming together. And we did have to do one more test because we were going to put one of the valves at a different fixture that I hadn't tested yet. So Becky's going to help me do that one right here. All right, so I'm going to test how long it takes for the water to get hot in our kitchen sink. So I got my temperature probe in there. You want to do the honors here?
Sure.
And Becky's going to...
I'm going to start it.
Start it. So go ahead, start. And then we'll swap over to the temperature probe app. And I'll record this so we have it too. But it's not showing up there. So we got 73 still going.
74.
20 seconds. Yeah, I can feel it getting a little warmer. So I've been trying to stop it right about when it gets to, upper 90s, 100s.
You want to see where it's, okay.
So 87, 89.
90.
Over here, we'll swipe it over. 97, 98, 99, about 100. So we'll stop there right about a minute. That's the fastest in the house.
Okay.
So, good for the dishwasher and for sanitizing our hands.
Okay, we're getting really close to the installation here. I did want to show you a little bit about where you can get the pump information on our website. You can see it here. It's pretty technical. We make great pumps, but we aren't as great at making super intuitive websites. Sorry about that. We did have one other hiccup that we needed to address, and that's the incoming pressure to the house. So most residential plumbing code states that the pressure coming in can't exceed 80 psi, or pounds per square inch. That's more than enough pressure to have a great shower and not have the pressure disappear when you flush a toilet or things like that. But you don't want it too high, because then it might start damaging your piping over time. So when we tested our pressure, it was sitting at right about 100 psi, so way over what it should be. That means we need to put in a pressure reducing valve. So in our installation, that was the first thing that went in, and then we could put in the pump. So that was one additional element here that I wanted to point out.
Now for the circulator install, we need to put, we're probably going to put the pump somewhere here, but we also have to put an expansion tank since the loop is going to be somewhat closed. So we don't have any big pressure spikes or anything like that. So we'll have an expansion tank that goes in here. We also had a discussion about the tankless heater. So if you don't know how a tankless heater works, essentially you have your cold water coming in from the city or whatever source it is, and then when there's a demand, a certain amount of flow that's going through there, so you turn on a shower or something like that. When there's a demand for hot water, this heater will kick on and when it senses a certain amount of flow, and it will heat the water as it comes in, and then it goes out to your hot pipe. The great thing about it is you have continuous hot water. As long as you pay your gas bill and your water bill, you will have hot water if you want to keep it running. The downside is you have to have a certain amount going through there. And that's always the trick with these circulators, because some of these circulators don't put enough flow through the system when they run to actually kick the heater on. So we need to look into that, and we'll see if this heater is capable of it. But the other nice thing about this Comfort Alpha is that its default setting is usually almost double what you actually need for these heaters. So it should be more than enough, but you can also adjust it to set it to whatever the minimum amount is for your specific heater. So I have no idea what that is for this one. This was installed before I came here, so we'll find out. But once that gets in, we'll test it and see how it works.
I don't have any problem with the cheap ones, but I don't see any reason that they'd be any worse.
So we're just putting in the one valve for now. We'll test it, see if it actually kicks on the heater, and then if not...
How would we do them in sequence? Wouldn't we have to cap the top?
No, it's not sequence.
I mean, like if we had to put two of these here.
Well, we'd have to put a 3/8 on, and then...
And it goes through both of them?
Mm-hmm. Yeah, what would we do on the top?
What are you talking about?
If we put two of these valves in?
I thought you could connect the end of that
No.
to the end of this one.
No, you don't put them together. You put one at the end of each branch.
No, but she was saying
She was
because
saying
of
we put
flow,
two in one
because there's a
spot.
problem.
Oh.
So when the tankless is involved, there's a problem with flow. That's how it determines how hot to get. This is only letting 3/4 of a gallon through.
Right.
If that
So
one
how
kicks
would-
on the heater, then...
So how would we put a second one next to it if we had to do that?
I mean, we could put one
Well,
in there.
And
but-
But no, we couldn't
I
do that
wouldn't,
because
I
it would
wouldn't,
get
I wouldn't
funky.
put it, I wouldn't put it next to it because that's not gonna provide additional flow if it's next to each other.
You basically
Because
come
that's what
out
makes
of the
serious.
hot on the left there, right, into the second valve.
We'd have to put a T.
Now, you'd have to do them in parallel. 'Cause if you don't do it in
yeah,
parallel,
okay.
it won't
Yeah.
increase the flow. So that's why
So
putting
you
one
put
at the other end
T.
of the house
Yeah,
is
you're right.
better.
You're right.
Yeah.
Because that's gonna provide flow going both
I
ways.
totally agree.
Yeah.
She was talking about two in the same spot, and I was like, man, intriguing. Let's see how this works. Yeah.
I
So
wouldn't
that's
know
not
how you
effective
do-
then.
I wouldn't know how you would do two in the
I
same
don't either.
spot.
I mean, you could put one there, one here.
No,
That doesn't. I mean, unless you teed off the service line to two sets of, but that's just still
But
weird.
then you'd need two faucets to go to. So I don't.
Yeah, I don't see how that would work.
yeah, I don't understand how you would do them in sequence.
You'd have to tee them back in on the top side too, or
Yep.
something.
Yeah,
That'd be weird.
and the problem is then the first one would get warm and the second would close,
Yeah.
and then it would never feed the second one. Whereas if you have one at each end of the tee, I think that would be better.
I agree. Two different locations.
But if 0.75 gallons is not enough, it should be enough to fire the tankless. But if it's not,
There's supposed to be a half a gallon a minute now to fire, right?
Well, it
No,
depends on the
101.
tankless.
Depend on the tank.
that's why he originally wanted to check the stats on the tankless, and they
Yeah.
got in that conversation.
Yeah.
Yeah.
But at first it made sense. Yeah, we'll just put them next to each other and connect them half like this. But then I was like, well, what do you do here?
Right.
You know what I mean? Like, do you cap these? Do we put this between them and cap these ends and bring one? Just make it one thing. And how, if it's only allowing 0.75 gallons, how does adding a second
All right, so we got the circulator pump installed and it's hooked up to the tankless. We have the valve installed here under our bathroom sink. And now I want to see what the temperature is of the water that's in the sink now. So pull out all my stuff. And as an aside, now it was just a little bit warm on the cold side, which is normal with these valves. So my suspicion then is that we're going to have nice hot water on the hot side. So let's see. Put my probe down here and we'll take a look. Open up the temperature. Good old Temu probe. We're at 81 Fahrenheit currently. So let's see what temperature we're at now. $9,800 immediately. Man, that's nice. All right, I just ran the pump and I'm at the shower here. I've got my temperature probe in place. I've got my app ready so we can check the temperature and we can see how long it takes. There we go. You see the temperature here, 68 degrees, 70, 73, 81. We're looking for 96 to 100 degrees. Last time I did this, it took about a minute and a half. 91, 92. So we're going to see how long it takes to get there after the pump's run. Now I will say, this is usually warm enough to jump in the shower and get started. 94, 5, 96. All right, 95. 96, there it is. And that took 45, 50 seconds. So that's a pretty good improvement over the minute and a half to 2 minutes that it took last time. And you can see it'll continue to climb. I think the hottest that I saw was right around 100 degrees, and that took about a minute and a half. But it does get hotter faster, which is a big improvement. And it's a welcome change, so you don't have to get in here to really cold water. But the experience on the faucets is a really dramatic change. It's hot as soon as you open the faucet. So it's really fantastic. But you can see this is a decently warm shower, 98 degrees or so, and it will continue to get hotter as the heater continues to run. But anyway, we're sitting at, what, just under 2 minutes, and it's kind of hanging out there, so we'll call that good. All right, so there you have it. The Alpha Comfort significantly reduced our hot water wait times. Showers went from a minute and a half to 45 seconds. The sink faucets are pretty much instant. We did use these Grundfos apps to set things up. This is the Grundfos Home app. We also used the Grundfos Go, and the Go is a little more technical. It's meant for more complicated systems and applications. The Grundfos Home app is sufficient for homeowners like you and me. I do think the apps could be improved a little bit. Some of the features are a little clunky and didn't really give a lot of practical help, but they just need some tuning. And I really like some smart home integrations as well. I'd love to be able to hook this up to Apple or Google Home or Amazon Alexa. I could see automating the pump with like a button or waving an emotion sensor or something to fire up the water before you take a shower. So there's that. But all this has been just a great, valuable experience, being able to use our products as a customer instead of being on the other side as a designer or developer. And when I used to work in technical support, I mostly heard about problems, but most of the people that I talked to out in the field, or they always praise Grundfos products. Like, oh yeah, Grundfos, great pumps, They always complain about our apps and our website, but there you go. Anyway, thank you so much for listening and watching. I hope this was informative and encourages you to see if you can use these same kinds of solutions for your home so you can save some water and hopefully get some hot water faster.